In this tutorial, we will look at exponential decay, and you can model decay as a constant percent decrease with the function below. So we still have a of t equals a times 1, and then there's a decrease, so it's minus r to the t. We don't need a to the 0. So a is our initial amount. R is our rate of decrease. And again, that's in decimal. And then t is the number of time periods. One minus r is the decay factor this time. It's a factor because we're multiplying by it, and it's decay because it's less than 1. And a of t is our final amount. So let's look at example number 1. We have Belka, North Dakota had a population of 16,000 in 1989, but has been dropping at a rate of 4.2% every year. Write an exponential function to model the population of Belka, and use a graphing calculator to graph it. So we're going to start off with a of t equals our initial amount, which is 16,000, times 1 minus, because it's a drop, and 4.2% is 0.042, and that is raised to the t. And then we can put that in the calculator, and we can look at what will the population be in 2016. So that would be 2016 minus 1989. So we need to see how many years from then. So 16 minus 9 is 7, and then 10 minus 8 is 2. So we have 27 years. So in that case, we're going to do a of t equals 16,000 times 1 minus 0.042 to the 27th, and see what our population was. And our population was 5,023 people, because we can't have decimal people, so we would just cut it off to 5,023 people. When will the population drop below 7,600? So we can go ahead and put that in the calculator and then look at where it drops below. So in year 17, it was 7,700 people, and then in year 18, it was 7,390. So we hit 7,390 after 18 years. So that would be 1989 plus 18. So 17, 9, 10, so 2007. In our next example, we have an ATV was purchased for $3,600, depreciates by 13% a year. So we're going to write our exponential. So a of t equals our initial amount, which is 3,600, times 1 minus 13 as a decimal is 0.13, raised to the t. And we can look at it in a graphing calculator, and we'll notice that it goes down. How much is it worth after 6 years? So we're going to look at a of t equals 3,600, 1 minus 0.13 to the 6 years. After 6 years, it was worth $1,561.10. And then when will the ATV fall below 2,000? So if we look at that in the graphing calculator, we find that it was above 2,000 at 4 years, and at the 5th year, it fell to $1,794.30. So go ahead and try number 3, pause the video, work out number 3, come back, check your answer. So go ahead, check your answer, see if you got the same thing, and then if not, check and see why not. And then for tomorrow, go ahead and do number 4 and bring your answer into class.